Hi, my name is Jesus Sanchez Cuadrado, and in this presentation I'm going to talk about ModelSet. ModelSet is a dataset of software models, in particular ECOR and UML models, intended to facilitate the task of building machine learning projects to address model-driven engineering problems. This is a joint work with José Antonio Hernández and Javier Cánovas. So, the motivation to build ModelSet was that we needed a data set in order to start applying machine learning techniques to model-driven engineering. And we found that in practice, there are very few data sets. There is a well-known data set which is labeled, um, but it is very small, only 500 models. And there are perhaps other large data sets, but they are not curated and the models are of low quality. So we decided to build a model set. So model set is composed of two sets of models, a set of 5,000 ECOR models taken from GitHub, and another set of about another 5,000 UML models taken from GenMyModel. So in total, we have manually annotated the models with more than 28,000 labels. And there are several types of labels. The main type is the category of the model. We represent the main application domain, like for instance, a state machine model or a MDENet model. We also have the tags, and the tags associated to a model refines the meaning of the category. For instance, we can say that a MDENet is a color MDENet, or that a language contains expressions, and we put all of this information in the tags label. Also, we have the purpose of the model, like it is for experiment or a benchmark, or it is a dummy model. Also, we try to record information like whether there is a notation associated or if the model is part of a tool. So most of the information that I'm going to give in this demo is available in this blog post. And also there are a few papers that you can check out to have more information about ModelSet. Now I'm going to start with the demo to show how to use ModelSet in practice. To start with, we need to go to the ModelSet main project in GitHub. And then in particular in this subproject, ModelSet dataset, we have the releases of the package that we can download. In particular, we go here, we click on modelset.zip, and we download it. So since this is going to take some time now, I have already downloaded here, and then you only need to unzip it to get the main folder, which contains several folders, like this one dataset, which has the ECOR and the UML databases for the labels. I'm going to show you this now. And then we have the raw data here, if we go here, raw data, we have the models for ECOR and for UML. And for instance, you see that we can take this, for instance, this one. We have this model in XMI format. Okay, and also we have the same data in JSON format to be consumed by graph-based algorithms, and in textual format, as we will see in the demo. Now I'm going to show you how the database is structured. Since it is a SQLite database, we can use the command line interface to make queries. Here, ECORDB is the database for eCore. And the first thing is to check the schema. The two important tables are models and metadata. Models contains the references to the models in the raw data folder, and metadata contains the labels in JSON format. So if we want to get all the models and the JSON metadata, we just need to create this query. First, we get the file name, the JSON data from models, joining with the metadata table on the ID column. Data. So here are all the models with the metadata. For instance, we see that this model jkind.ecore has these labels in particular. The ones that are, let's say, officially supported are category, that in this case indicates that this is a simple programming language, tool, which is jkind in this case, and tags, because it says that this model contains expression, types, and it is about programming. And also about a reference language called Lustre. We can see that there are other models, for instance, this one, which has the category dummy, indicating that this is a model that it is of very low quality. Also, since SQLite has support for JSON functions, we can create more sophisticated queries like this one that allows us to get the count of the main category. So we have that dummy is a very important category because there are a lot of low quality models. Then we have state machines, Petri nets, and so on. Now that we know how to, we know that we have the SQLite database with the labels. We know that in the raw data, folder, we have the eCore, for instance, and the UML meta models. Sorry. Okay, you see that here we have data, which is exactly the folder that is the beginning of the file name path in the database. We can use this to actually process use the dataset. However, since this is a bit, it's not complicated, but it requires some coding, we have created a support library in Python that you can install with pip. Okay, we have already installed it, but you can just do it to install our library, and then we can go to Jupyter to do a small example project. So in this case, I have already prepared an example. It is a feed-forward neural network to classify models according to its category. So to use the model set using the Python library, we just import the ModelSet dataset object, and this object contains the load method, which takes the location of the dataset in the local installation, the model type that we want to use, either eCore or UML, and optionally we can give the analysis that we want to make. For instance, for us, we can ask that it computes stats about the models. This takes some time, so we are going to remove it in this case, since we are not interested. So we load the data set, and then we see that there are the promised models. And then we use this method to normalize df to get a pandas data frame to easily manipulate the data set. The options are mean occurrences per category, which means that we don't want models whose category has less than 10 models associated. We only want models in English, and we don't want models with the category name unknown, because these models are actually models for which we don't know an appropriate category, so we mark them as with unknown. So we get the data frame, and we can check the contents. You see that we have the ID of the model, the category, and the tags, and the language. Then what it is nice is that we can perform queries. For instance, we can get all models with the dummy category, or we can get all models that has a tags label associated. You see that the different tags are concatenated with this bar that you should split to use them. Okay. And now in this project, what we are going to do is to split the data set into test and train. So we get the IDs. And for this, we are going to use scikit-learn, which is very convenient. So what we do is to get the IDs of the models, we get the category as the target label, and then we perform the splitting. Okay. Now, what it is important is that to train a neural network, we need to give a vector to a neural network. So we need a way to transform the model into a vector. In this case, what we are going to use is a textual representation of the model. As I already said, if we go to the ModelSet package, in here we have the textual representation of each model. So for instance, we go to the equal all, and we get boost, EMF tools. Okay, we see that for this model, we have the textual representation, which is basically, I'm going to look at the contents, which is basically all the string attribute values of the model. Okay, and what we do with this piece of code, and in particular with this method of ModelSet txt file, what we do is given an ID, we get this associated file name, right? And basically, we get the file names for the training dataset and the file names for the test dataset. We give these file names to the TF IDF vectorizer of scikit-learn, and it takes care of everything and returns a very big matrix with a vector representation of each model. Okay, now the only thing that we need to do is to use a standard classifier of scikit-learn. In this case, this multi-layer perceptron, which is a neural network with this size for the hidden layer. We just train the model, and then we wait a bit for the result. The interesting thing is that the support library that ModelSet offers gives almost everything to us, because as you see, the only thing that we need to do is to load the library, get the pandas data frame, and then what we are doing is just to use standard Python libraries to perform to perform the task that we want to do. Now the classifier has been trained, and what we do is to evaluate the classifier. So we do it, and we see that using the accuracy as a metric, if we apply the model for the entire training data set, we get a very good result, of course. And then for the test data set, we get also a good result, which indicates that this model is good enough. So with this, I would end the demo. So if you have any question, please don't hesitate to ask it. Thanks.